In this video, we will talk about how neurons communicate with each other. There are two stages in neuronal communication. The first one is the electrical conduction, moving signals within a neuron. So we will move from the dendrites to the cell body and then throughout the axon. Then the second stage is the chemical transmission. So this is the between neuron communication. So we will move the signals from one neuron to another at the synapse. In neurons, action potentials play an important role in cell-to-cell communication. A neuron is at rest when it is not sending any signals, and we call it the resting membrane potential. So there is a difference in the electrical charge between the inside and the outside of the neuron. So we call the inside of the cell intracellular and the outside to be extracellular. The inside is more negative than the outside. And then we will measure the potential of the membrane by millivolts. So this is the distribution of charge. And during resting membrane potential, the potential is around -70. And here we have more sodium outside the cell and more potassium inside the cell. So then the next stage will involve more sodium coming in and then more potassium leaving the cell. So remember, in the first stage, there were more sodium outside the cell and more potassium inside the cell. So in this stage called depolarization, this is when neurons receive a signal and then more sodium will come into the cell and then the potassium will begin to leave the cell. So this will reduce the negative charge inside the cell. Remember, in the resting membrane potential, the millivolts is around -70. So this will reduce the negative charge and then increase the charge to around -55, which is called the threshold, and then it will trigger an action potential. Now you may wonder what happens during an action potential. So an action potential will move the signal all the way down to the axon and then to the terminal button. And no action potential will take place unless we reach the threshold, which is -55. But once we reach there, the action potential will always fire, and we call this the all or nothing principle. And the size of the action potential is around 30 to 40 at peak. After an action potential has taken place, it will begin to move back to the original resting membrane potential, called repolarization. So here we have the sodium channels closed and then the potassium channels open. So potassium will move out of the cell. The channels will remain open even after reaching the resting membrane potential, so around -70, and then they will even move beyond to around -80. Then we will enter a stage called refractory period, so this is when another action potential will not be possible. And finally, we have reached the stage of hyperpolarization. So this is when the potassium channels close, and it allows the return to the resting membrane potential of around -70. And here we are able to generate another extra potential. Now you could pause the video for a bit to see if you could remember different components of the potential. I've put out the answers up here for you to check yourself. Remember, we talked about the role of the Maiden shift in speeding up the action potential. So it can help cover much of the axon, and then action potential don't need to occur at every small little segment of the neuron. So in this animation, you can see that the Maiden will speed up the whole process. And we call this as the saltatory conduction because it jumps from one node to one node and then speeds up the whole process. Now that we have moved the signal all the way down to the axon, we will need to release the neurotransmitters. And here the neurotransmitters will bind to the receptor sites of the receiving neuron. And on the receiving neuron, there are a lot of different receptors. It acts like a lock and key system, so it will bind to the receptors. In this video, we have summarized the whole process of the cell-to-cell communication. In the next video, we will talk about the nervous system, and I will see you in the next one.